Hello, I'm Curtis Dyerson. I'm a computer scientist at Utah State University. This is joint research with Mary Barkworth, Vishal Sharma, Arihant Jain, and Joshua Webster at Utah State University, Neil Cobb, Evan Dunn, and Ben Brandt at Northern Arizona University, and Will Pierce at Imperial College. This talk is in two parts. I'm going to talk to you about Symbiota2, and in particular about data standards within Symbiota2 and the use of standards within Symbiota2. And Neil is going to talk to you about fairness. Well, Symbiota2 is a web database application, and it's a rewrite of Symbiota. Both projects were funded by NSF. Symbiota is a widely used database application for managing specimen collection data. Who collects specimens? Herbaria, natural history museums, and others. This map shows Symbiota collections within the United States, but Symbiota is used within other countries as well. Today I'd like to tell you the story of a data value within Symbiota2. In particular, I'm going to focus in on the SciName, which is the scientific name of a specimen within the Symbiota2 database. So life begins for this value within the database, and Symbiota2 is stored in a relational database. This relational database is somewhat complicated. This diagram shows the MySQL Workbench entity relational model for the database. In this diagram, every node represents a table in the database. The columns within that table are listed in a very, very tiny font. It's impossible to see in this diagram because there's so many tables and the database is quite large within that particular node. The edges between the nodes are foreign key relationships between the tables. And what we're going to do is we're going to focus in on the taxa table. And within that taxa table, we're going to look at the SciName column. And that column is represented by that tiny blue oval right in the middle of this particular diagram. The next step in the life of the SciName is to move the SciName from the database into the front end of Symbiota2 so that users can see it and edit it and so forth. So for every piece of data within Symbiota2, we provide two kinds of services, a GET service and a PUT service. The GET service reads information out of the database, providing it to the front end, and the PUT service puts information from the front end into the database, and all access to the database is through these services. In order to support the web services, what we're going to provide is a web service specification. This specification is independent of any particular database management system, so it doesn't matter if it's Postgres or MySQL. It's a high-level specification, given at a very abstract level. And from this specification, what we're going to do is we're going to generate web services from the specification. Now, the specification provides a very important mapping, and this mapping is between tables within the database. These are relations within the database, and objects provided by the web service. So the web service maps this relational data, this tabular data, into a hierarchical model. This hierarchical model represents an object, and this is called an object-relational mapping system. Now, unfortunately, from a standards perspective, there's no standard for this specification. Instead, the specification depends on the kind of tool that we're going to use. For Symbiota2, what we're going to do is we're going to write Symbiota2 in TypeScript. And for TypeScript, there's a tool called TypeORM, so Type Object Relational Mapper. And here's an example of the specification for the taxa table. And in this particular specification, in the middle we see the scientific name, which is mapped to a string in the object. And this is a very simple specification. And it just takes this one table and dumps it out as an object. But from this specification, we can build a web service that provides read and write access to this data. So using TypeORM, we can specify web services, and these web services will provide communication between the back end of Symbiota2, the database, and the front end of Symbiota2, the graphical user interface, which is a web browser. And using these web services, we can transfer data back and forth between these two parts of Symbiota2. Now, the only standard that's used within this web service specification is the OpenAPI standard. And OpenAPI is typically coupled with web service specification tools like TypeORM and Doctrine, and it documents what the web service, the information that the web service provides, and allows for discovery by web service search engines. But thinking more broadly, how can this scientific name value within a particular Symbiota2 database be connected to the larger body of information that's out there in the world? So how do we integrate Symbiota2 with other data collections? Well, the first kind of connection we can make with other data collections is that we can export Symbiota2 data in Darwin core format. So Darwin core is a standard format for representing specimen data. In this case, for Symbiota2, we provide simple Darwin core data. This Darwin core data is exported as XML, as shown in this particular diagram. And our scientific name is this particular XML element, DWC scientific name. And it is exported within a Darwin core record, within a Darwin core record set. And this Darwin core data can be collected by engines that harvest Darwin core data. The second kind of connection that Symbiota2 can make with other data collections is through the export of a Symbiota2 knowledge graph. Now, the idea behind a knowledge graph is what it's going to do is it's going to glue together information from sort of different communities. Now, if we think back to the Darwin core example, Darwin core is a standard for exchanging data within a specific community, the biological specimen collection community. And if we want to market or export a biological specimen, we produce it in Darwin core format to be harvested by people who want to utilize that information, that knowledge. But communities have different ways of representing their information, different standards. And so how do we glue together all the different standards into a combined whole? Sometimes these communities are independent, but often it's the case that they have interlinking or interdependent information. And a knowledge graph is a way to build connections between these different community representations, these different standards. Now, knowledge graphs are useful, and here's an example of how knowledge graphs can be used, and it's a Google search. And in this Google search, I've punched in Einstein, and the left-hand part of the screen shows a typical Google search where we bring up pages associated with the search for Einstein. But the right-hand part of the screen is a little box, and this little box is information about Einstein brothers bagels. And this box is produced by the knowledge graph that Google pulls together that has information or data about Einstein's brothers bagels. So where does this information come from? Well, here's part of the graph that Google builds, or Google uses to build up their overall knowledge graph. So they get information out of Wikipedia, DBpedia, a bunch of different data sources, and they look for connections between these various data sources, between the information provided by these data sources. The connections between these data sources are mappings or so-called ontologies between the vocabularies used within these particular standards, within these particular data collections. So how can we contribute to this knowledge graph that's going to be used by Google and used by others? Well, for the Symbiota2 knowledge graph, what we're going to do is we're going to use a W3C standard called R2RML. And in this particular R2RML standard, what we're going to do is we're going to take our relational database and we're going to map it to a knowledge graph. Now, this graph is going to be generated, or this graph is going to be represented in the resource description framework, RDF. And here's an example of this mapping. And in this particular mapping, we focused in on the sign name, our little data value. And so this is the sort of the end of the lifetime of our sign name data value. We've exported it out there into the world so that it can be harvested by Google and integrated into Google search. In summary, the life of the scientific name within Symbiota2 is a little bit complicated. We'd like it to be a simple story, but there's a bunch of different standards involved and a bunch of different ways that the data is exported. It's exported as using a TypeORM specification. It's documented using an Open API standard. It's exported into Darwin core standard that's not connected to the TypeORM specification. It's also mapped to a knowledge graph using R2RML. And so the problem really here is a plethora of standards, and there's no single specification. I think a single specification would make life easier for everybody, but I don't know of any tool that does that. Thank you.